In section 3.3, we'll be able to prove lines are parallel. In the last section, 3.2, you saw that if two parallel lines are cut by a transversal, then corresponding angles, alternate interior angles, and alternate exterior angles are congruent, and consecutive interior angles are supplementary. In section 3.3, you will find that the converses are also true. So remember, converses are when you just flip the conditional around. The hypothesis becomes the conclusion, and the conclusion becomes the hypothesis. So for example, if we stated before, if two lines are parallel cut by a transversal, then corresponding angles are congruent. The converse of that would be if corresponding angles are congruent, then the two lines must be parallel. And you'll see just that in the next slide. So now we're going to see just 4 more postulates or theorems that are the converses of the theorems and the postulates that we saw in the last section. So the postulate 16, corresponding angles converse. So in the last section it was if the two lines cut by a transversal are parallel, then the corresponding angles are congruent. Again, we're going to flip that around in this section and state if two lines are cut by a transversal so that the corresponding angles are congruent. So this time if we know the angles are congruent, then we can conclude that the lines are parallel. The next theorem is the alternate interior angles converse. In the last section, it was stated if two lines cut by a transversal are parallel, then alternate interior angles are congruent. Now in this section, if we know that the two lines are cut by a transversal and alternate interior angles are congruent, then we can conclude that the lines are parallel. So again, if we know the interior angles are congruent, then the lines must have been parallel. Moving on to the next theorem, alternate exterior angles converse. In the last section, we stated if the two lines cut by a transversal are parallel, then alternate exterior angles are congruent. Now in this section, if two lines are cut by a transversal and the alternate exterior angles are congruent, then we can conclude that the lines must have been parallel. And the last theorem is the consecutive interior angles converse. In the last section, we knew that if two lines are cut by a transversal and they're parallel, then consecutive interior angles are supplementary. In this section, we know if two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. So remember, consecutive interior means that they're on the same side of the transversal, and this is the only angle pair that are not congruent. Consecutive interior angles are supplementary if the two lines are parallel. Now in this section, if consecutive interior angles are supplementary, then we can conclude that the lines must have been parallel. Now on to the examples. We'll just be applying all of these converses. So example number 1, find the value of y that makes A parallel to B. And now looking at the diagram, we see we have one angle, 5y plus 6, and it's on the outside, so it's an exterior angle, and 121 degrees also on the outside, so it's an exterior angle. They are on opposite sides of the transversal, so here we have alternate exterior angles. If these alternate exterior angles are congruent, that would mean that line A is parallel to B. So what we're going to find is the y value that would make these two angles equal to each other so that we can use the alternate exterior angle converse theorem in order to prove that A is parallel to B. So we're just going to set up the problem and put 5y plus 6 equals 121. If I subtract 6, I get 5y equals 115. Then dividing by 5, I would get y equals 23. So what this means is if y was equal to 23, that would make this angle equal to this angle, and therefore alternate exterior angles would be congruent, and that would make line A parallel to B. Example number 2. Marie was stenciling this design on her kitchen walls. How can she tell if the top and bottom lines of the design are parallel? So what she wants to know is if this line on top is parallel with this line on the bottom. If you look here, we have several transversals cutting through those two lines that she wants to tell if are parallel. Just picking one of them, let's say we're going to look at just this transversal right here. If she could somehow measure if this angle right here is congruent to this angle right here, then we would know by the alternate interior angles theorem converse that the two lines on top and bottom are parallel. So again, if she could somehow measure that this angle and this angle are congruent, then alternate interior angles are congruent, which would make the top line and the bottom line parallel to each other. So my answer is Marie should measure the alternate interior angles to see if they are congruent. If they are, by the alternate interior angles theorem converse, the top and bottom lines would be parallel. Example 3, can you prove that lines A and B are parallel? Explain why or why not. So looking at the first diagram, we're trying to decide if line A and line B are parallel. The two angles we are given as congruent are alternate exterior angles. By the alternate exterior angles theorem's converse, if alternate exterior angles are congruent, then the two lines that are cut by the transversal are parallel. So in this case, A and B would be parallel by the alternate exterior angles theorem's converse. In the next diagram, we are given that this angle is congruent to this angle. So we're again trying to decide if line A is parallel to B. If I put line A on top of B, these two angles that are marked as congruent are corresponding. We do have a theorem that states that if corresponding angles are congruent, then the two lines would be parallel. So these two lines are parallel since the corresponding angles are congruent. And in the last diagram, we are given that angle 1 and angle 2, when I add them together, they equal 180 degrees. That means that angle 1 and angle 2 are supplementary. Looking at the diagram, angle 1 and angle 2 are alternate interior angles. If lines A and B were parallel, alternate interior angles would be congruent. We are told in this problem that these alternate interior angles are supplementary. Therefore, we cannot prove that lines A and B are parallel. So my answer would be no, because alternate interior angles would need to be congruent, not supplementary, for the lines to be parallel. And we'll end this section with a theorem. It's called the transitive property of parallel lines. So remember, the transitive property basically said that if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then angle 1 and angle 3 would have to be congruent. So angle 2 is what they had in common, meaning it's the thing that linked angle 1 and angle 3 together. The transitive property for parallel lines works much the same. If two lines are parallel to the same line, then they are parallel to each other. So for example, if lines P and Q are parallel and Q and R are parallel, then P is parallel to R. If you see here, just like the example I gave with the angles, Q shows up in both of them. P is parallel to Q, and so is R. So Q is what they have in common. So if P is parallel to Q and Q is parallel to R, then P also has to be parallel to R. So it's, again, just like the transitive property, you find that link that they have together, linking P to R, just like before. We're not going to do an example over this because I think this is a lot like the transitive property, and a lot of you have a good handle on the transitive property. So this will be a problem that will be covered in your homework, but again, we're not going to do an example problem over it. So as always, if you have any questions, make sure you jot them down so we can cover them in class before you're expected to do your homework in class, and we'll see you then.